Hello all, welcome to the new video. Here in this particular video, we are going to discuss what is Docker and what is the architecture behind the Docker and what is the images and the containers, how it will be built and what is the networking and isolation within your Docker and how the storage will make a persistent in Docker and some practical workflow and tips we are going to discuss in this particular video. Without further ado, let's enter into the video and have a discussion around it. First of all, what is Docker? Docker is a platform that packages a specific, sorry, that packages application into a lightweight portable containers. Okay, remember it is a lightweight and portable containers. And what exactly the problem it solves was it works on your machine, ensures consistent environment across the development, testing and production. You may heard it is working in developer mission, it was not working in another security team or testing team environment. So basically that problem will be resolved by making all the environments will be consistent, like development, testing and production. Okay, and like containers versus virtual machine. If you see, the containers share the host kernel, that means your host machine OS kernel will be shared, making them faster and more resource efficient. But in the case of virtual machine, it uses its own operating system on top of your host OS kernel. Okay, and the key benefits of Docker was applications can run the same way anywhere. That might be in your laptop or server or cloud. That is the use case of Docker. Okay, and if you see here the how the architecture behind the Docker and the virtual machine, this is the virtual machine. Okay, so the guest OS is installed on top of your host OS kernel. Okay, and it basically a heavy and includes a full OS, and it is more secure compared to other. Okay, and coming to the container, it is like whatever the app dependencies will be there, that will be only packaged. And coming to the OS, this will be used by whatever the host OS is there, that OS kernel only it is there, and on top of Docker will be there, Docker engine basically. Okay, and it is basically a lightweight and shared OS will be performed in the case of Docker containers. Okay, and coming to the architecture of Docker. Okay, it basically follows a client server architecture model. Okay, basically this is a client, Docker client, and this is a server. Okay, basically Docker host, we can say this one. And here in Docker client, we only have a Docker CLI. Okay, so this is going to talk with the Docker host. Okay, this is a server, and sorry, this is a client and this is a server. So it is going to talk with the help of REST API. Docker uses REST API to connect with this, and we can maintain the same Docker client and Docker daemon, which is a server, client and server in the same mission, or else we can isolate the different environments, but it works the same functionality. Okay, and here on top of it, it have a container engine, and it includes images will be there, and containers will be there. Okay, with the help of daemon, it was building the images or running a containers. Okay, so Docker daemon is the actual worker machine, we can say, which performs the work on behalf of Docker client. Okay, and there is a Docker registry also, which is like a Docker hub, we can say, or else any cloud platforms also, we can say, like ECR, like that. Okay, and basically here a registry in the sense, it is like how the GitHub is there, it is like Docker hub. Okay, so we can store the images in the registry, that is the purpose. Let's say if you use example like this, Docker run nginx. Okay, so basically from the help of Docker client, you are passing this particular command to the daemon. Okay, so with the help of this, you are passing this command to the daemon. Okay, so what exactly the daemon does, daemon try to run this particular image. Okay, so it will checks in the local, that means in the host mission, and if the image is not available in the local, then it will go to the Docker registry and then it will get from there. If there is no image with this particular name, then it will give a error. Okay, that is how exactly it works. Okay, and coming to the points here, like the same points also covered here, like Docker client, which is a command line tool, where Docker CLI we can say, or Docker desktop GUI, also graphical user interface, it will be provided if you download Docker desktop. Okay, and it is basically to interact with Docker Daemon. Okay, with the Docker. Okay, and Docker Daemon, basically it is a background service that manages a containers, images, and networks and volumes. All will be managed by the Docker Daemon only. And coming to the command flow, basically a client sends a commands to a daemon via the REST API, as we discussed, and Docker registry, it will basically stores a Docker images like Docker Hub, Elastic Container Registry, which is AWS, ECR, Amazon, ACR, Amazon Cloud Container Registry, Google Container Registry, like different registries are there. Okay, and moving to the next slide, which we are going to discuss about images and containers. What exactly the images and containers? Basically, Docker image is read-only template with application code. Okay, and its runtime, libraries, and dependencies. Okay, these are the like essential things. Whatever it is required, that will be kept in a Docker file image. Okay, so that is basically a Docker image. The Docker image will be built from a Docker file. Okay, and basically a container, if you see here, this is the workflow actually. Okay, Docker file, Docker image, and container. Here in Docker file, it all the build instructions will be there, and we are creating a image by using a Docker build command. Okay, hyphen t, in the sense we are giving a tag, that means image name as my app. Okay, now here image name is my app. It is dot indicates the current directory, that means your Docker file and your all the code is located in your current directory. Okay, that is the indication of this particular command. And once I mean this is this command. Okay, for Docker file to Docker image. Once the Docker image is created, then it is like only instructions, a Docker file. Okay, and it is like read only template image, and we need to run that particular image, that makes a container up and running. Okay, so this is the actual command, Docker run app. This is the actual command here, in between Docker image and Docker container. Okay, Docker run and your image name, basically that will runs your container. Okay, and we can specify some more arguments like hyphen d, which run in background, which is in detached mode, hyphen p, which maps a port, and hyphen b v, which we can attach the volume mounts and volumes and mount points. Okay, that is a different, I will discuss that options also. Okay, and basically container is running instance of an image, like a process with its own file system. Okay, and Docker file, as we already discussed, it is just like plain text that have all the instructions to build an image. Okay, there is no dedicated specific language, it is a domain specific language. Okay, DSL we can say. Okay, it this particular language will be only understood to the Docker. Okay, it looks plain text only. Okay, and relationship of one image can create a many containers. This is also one of the important point. Okay, with the help of same image, we can build a multiple containers. We can run and we can up and run a multiple containers out of the same image. Okay, that is the use case here. And moving to the next one, which is a Docker component again, which is isolation and networking. Basically, Docker networking makes a Docker which is isolated. Okay, so if you see here, uh, isolation process, which basically each container runs its own namespace. That means it cannot see others containers by default. That is the like default behavior of the container. Okay, so And there is a resource limits also. We can control the CPU, memory, and disk usage per container. Okay, that is also possible. And network isolation also possible, where containers gets their own virtual network interface, and port mapping also will it can be done. Let's say if we wanted to expose our container port to a host machine, then we need to use this particular thing. Okay, hyphen p is basically publish. Okay, and in the small form we can write hyphen p. Okay, or else hyphen publish also we can write. And 8080, which is basically your host machine, and in container it serves in 80 port. So what exactly you are doing? In container my app is running in 80, so in the host machine you can access in 8080, like that it is meaning. Okay, and container network, it will be basically creates a network for containers to container communication, to make a container to container communication. Okay, so if you see here example, container network example. Okay, here there is a web app in which is running in 3000 port in the container. Okay, and database which is running in 5432 in the container. Okay, and redis, which is also a database, cache database we can say, which is running in 6379 in container. Okay, basically docker network, um, you can make sure to communicate uh, from one container to another container if those are in same network. Okay, let's say if this also have a same network, this also have a same network, and this also have attached a same network. In this case, web app can talk to database, and database can talk to redis, like that. They can communicate each other. Okay, and yeah, that is the significance here. And moving to the next slide, where we are going to discuss about persistent storage. So here volumes comes into picture. Earlier we have discussed about networks. Okay, so volumes and networks is something more important in your docker. Okay, to understand how exactly it will works, like that. Okay, so here let's say persistent in the sense, basically by default the docker, let's say if you start a one docker container, and if you did some work in that particular container, and some logs is generated and some files is created, so whenever you restart that container or rebuild that particular same image and build a container, then it won't store the earlier data. Okay, so to maintain that data, that means persistency, storage, we are going to use a volume concept. Okay, so container file system, which is temporary, data will be lost when the container is deleted or restarted, like that. Okay, and docker volume, which is managed by a docker and stored outside container life cycle. Okay, so basically this particular docker volume will be stored in the host machine. Okay, and that particular volume can communicate with the docker container, we can attach that way. Okay, and basically here bound bounds, which is we are going to link a container directory to a host file system path. Okay, with the help of specific path, file system path, we are um, linking the container and the host file system. That is basically a bind amounts. Okay, there are two differences: docker volume, which is managed by a docker, and that will be stored outside the docker, which is in docker in the which is in a host machine. That is the docker volume. And bind amounts is something different. Okay, with the help of specific file path of the host, we are linking container and host. Okay, so use cases, we can let's say if you have your database files or configuration files, logs files, user uploads, anything we can be stored with the help of this. Okay, and coming to the benefits, data survives and containers whenever the container restarts or updates or deletes, like that. Okay, so if you see here, this is the host data. Okay, and this is the container. Okay, so within the container, this is the directory. Okay, where the data is be stored, like that. We are just giving an example. Okay, within the container, slash app slash data, that is where your pointing out the data. Okay, that means if you see, as I said, here Docker volume is different, Docker mount is different. Coming to the Docker volume, okay, basically this will be managed by a Docker, okay, and which will be stored outside the Docker container lifecycle, which is in the host system. Obviously, host system is outside the Docker um container lifecycle, right? So your volume will be stored in this particular directory, okay, in the Docker host machine, and it will be mapped to this particular directory in the container. That is the significance here, okay. And if you see here, the command also says the same, docker mount, uh, yeah, volume mount, sorry, docker run hyphen v, my volume will be the volume name, and then this is the path inside the container, okay. Basically only this is the path, okay, slash data, okay. Here app slash app slash data is there, right? Like what here also same, okay, slash data will be the path of this, and this is the like image name, my app, okay. And coming to the bind mounts, it is basically the path system in your host machine, and you are connecting to this. This is the command we are using, docker run hyphen v, this is the host file system path, and this is the container file system path where this will be mounted to this, okay. And whatever the data comes here, that will be stored here also, okay, in host machine, and this is the image name. And yeah, moving to the next slide, which is last slide, where we are going to discuss about some practical workflows, sorry, and tips. If you see some real use cases, real commands, these are the some Docker common commands. Okay, Docker pull, basically it will pull a image, Nginx image, okay, from the Docker register, which is Docker Hub, and Docker build hyphen t, which is we are building the image, okay, from the Docker file, okay. And then Docker run hyphen d hyphen p hyphen name, port binding also done here, hyphen name, that means you are giving your container name as web, and this is the image name. Basically you are starting your container here, okay. And to list a running containers, this is the command docker ps. Let's say if you wanted to list running containers and stopped containers also, then you can use docker ps hyphen a command, okay. And basically this command will list all the logs for this particular container, okay. And let's say if you wanted to go inside the web container, okay, so this is the command docker exec hyphen it, which is interact to terminal will be opened, and then this is the like default path. And then docker stop, which is you are stopping the web container, and then you are removing that particular container, okay. So let's say if you wanted to stop and remove forcefully whenever the container is up and running, in that case you can use hyphen f command, okay, hyphen f tag or argument in the same command, this particular command, okay, sorry, in this particular command, okay. You no need to stop and then remove, you can directly remove if you use hyphen f, which is forcefully removing, okay. And docker images, it will list all the images, okay. And let's say if you wanted to clean up everything, docker system prune, it will removes everything like containers, images, and like whatever the data is there, that everything will be lost, okay. And coming to the some best practices, use a lightweight base image like Alpine, Slim, like that, and minimize the layers in your Docker file, and basically Docker image, okay. And don't run as a root. That is also one of the best practices. And coming to the security best practices, keep the image updated, up to date, and scan for your vulnerabilities by using some tools, which is Trivi, Snake, like that, okay. And then use a secret management for storing the secrets and credentials. And coming to the performance, let's say performance wise, what is the some best practices need to be followed. Set the resource limits, okay, to do not to exploit or don't perform DDoS attack of the like some outside person. Okay, use the multi-stage builds. Okay, basically that will helps to reduce the layers and docker layer, I mean leverage docker layer caching. Basically reusability need to be there whenever it is possible. That is basically here. And coming to the some docker interview questions, which is what is the difference between cmd and entry point within your docker file, and container versus your image. Okay, and docker versus your virtual machine, volume types. Okay, so these are the points. And then coming to the like final point, which is a typical workflow where the developer writes a code, and then they are also creating a docker file, and then with the help of a docker file we are building a docker image. Okay, and then we are going to test locally whether it is working or not. Then we are going to push that into a docker registry, and then we are going to deploy into a production. This is the basic workflow. Okay, yeah, I think we are good to conclude. We have covered almost good pointers about your docker. Okay, and yeah, stay tuned for more videos. Thank you so much for watching the video.